computer. Okay, there we go. So we're gonna start recording meetings again. We do have a YouTube channel, and our last recordings were from fall 2020, where Nico was teaching and I was a student. Oh, by the way, please turn up your cameras if you want to. If you don't want to be seeing the recording, because this is going to YouTube and it's going to be public. But yeah, we're gonna be uploading new recordings from this iteration of BeginnR for the people who can't make it or prefer to make it at another time. Then yeah, office hours, please fill those in. And we're going to be sending all of our information through Slack. So if you know somebody who's not in Slack, which I'm pretty sure is the case for many of the people that signed up and they're still not on the channel, please let me know. I'm going to reach out to them individually still. And we're going to be opening a form for C1s. Remember that C1s are a challenge one independent project. Basically, it's choosing a topic of your interest and trying to find a data set that's fun and that might answer a question that you have in mind, and then just looking at the data, see what it has to say. We're planning to have a C1 session with Nico, me, and a couple of the other section leads next week. So we're gonna be opening when to meet to sign up. The only thing you need for the C1 first session is like, one, have a topic that you're interested in, two, have a question that you want to answer on that topic, and three, trying to find a data set that you think has a decent amount of information. So example, I did mine on foreign aid from the US to other countries. So I literally Googled foreign aid US. And I got this from like a government website that had all my data. Easy. Just like download, and then I just saw like all the things they had. They had like data from like 9/11 onwards. So it was super complete, and I just knew that probably most questions that I had, I was going to be able to answer them. On that note, though, please have a question in mind. The only thing I regret from my C1 was I didn't have a question, so I spent like hours looking at different hypotheses that were like dead ends. So as long as you have something that you can answer, that's really good. Any questions about C1s or any of this in the chat, or just speak up? Okay, sounds good. Great. We're going to be doing a quick review of R files, just because some people asked last time, like, what was the difference between their files? Why couldn't they see this button to insert a chunk, etc. So if you go to like, okay, first of all of the files in this workshop are going to be .rmd files. That basically means our markdown files. It's the normal like layout where you have like your comment section here in black in my computer and your chunk section where you run your code in gray in my computer. So this is like an R markdown. It's easy because you can like separate the part where you tell like your story, or you write instructions, or you write like comments or any like useful notes, from the part where you actually do the coding. And I think it's just like much easier to see like step by step, what am I doing with the data? Am I reading the data in? Am I step 2, changing a column in the data? Step 3, am I doing a graph, etc. So like when I want to look for something, it's much easier than, for example, if I go to File, New File, and our script. Our script literally does not have chunks. Like everything you do within our script is like the same background thing. So it's like much more difficult to see like where like things are in the data and that sort of stuff, and like separating your comments, instructions, whatever, from the rest of your code. So this type of file, the R script file right here, we only recommend for like finished products. So like if you're doing a C1, you're probably better off going to File, New File, and R Markdown. R Markdown is the same thing that we're using for this, the RMD file. Do our markdown for your C1s, and then when you have like a finished working product for like yourself or a client or whoever, do the script. Why? Because the client is probably not going to care so much about like these notes on the outside, just like having function and code. And it's called a script because it's like meant to be read as something that's like ready, as something that works. So like only use our script when you have like something that is ready. Otherwise, like when you try to run the script, it's going to have to run like the entire thing. Whereas here in the R Markdown, you can like do comments, etc., and run like chunk by chunk, which makes it much easier. Any questions up to this point? Okay, sounds good. So we're gonna start with a demo now. We're gonna first read in Tidyverse. Easy as always. Whenever you open a new R Markdown file or any sort of R file, you need to read in the packages that you're gonna use. Just a note, if you're using like more than one package, which we're going to be using later on in the workshop, but for now Tidyverse is good. If you're using more than one package, we recommend that you write all those packages in the first chunk, just because it makes it much easier than having like, it's much easier to have like library 1, 2, 3, 4 than having like all of them mixed up in your code and nobody knows where they are. And also the libraries have to be read in before you can actually use the functionality. So read them in at the start and you're going to be fine. Some interesting packages that come within the Tidyverse package, we have Ggplot, which we're going to use to do graphs. Ggplot is going to be like the thing you swear by in beginner, and whenever you do like any sort of graphs in R, it basically like does a super nice plot for you. Tibble is the same thing as a table. Take tibble as a table, like any data set that you have that has rows and columns. And yeah, deep layer is what we use for like pipes and that sort of stuff for data manipulation. So like those are your big three things. You don't really need to know this, just like for context, if you're ever running into trouble with any of these are packages they belong to. Okay, moving on. The Tidyverse package has this data set called MPG that is built into it. If we want to, for example, open the help menu right down here at the bottom right and tell us like what this data set stands for, we would do F1 in a Windows, or in the case of a Mac, F1. Note that you have to put your mouse on top of the thing that says MPG and then do F1 to make it load down at the bottom right here. So this MPG dataset contains a fuel economy data from this year to this other year of popular models of cars. This is the description. Then if you want to use it, you just type like MPG and that's it. For example, if I type MPG and I run this chunk by pressing the play button, it's going to appear. And then I have the variable names right here and the description of what they stand for. So like these are pretty straightforward. But for example, this means engine displacement. Sil means number of cylinders. Trans means type of transmission. DRV means the type of the drive, like front wheel. F stands for front wheel. R for rear, and 4 for four-wheel drive. CTY, city miles per gallon. HWY, highway miles per gallon. FL, fuel type, etc. So like those are the types that we have. Honestly, if I scroll to the right using this arrow, we're going to see like more of those columns. But that is basically the description that we have up to the moment. Any questions? That's it. How can I pull this up without the keyboard shortcut on a Mac? If you mean the help menu, you can just do like question mark before MPG, as we did last time, and then run this, and it's going to appear right here in the search results. And as I mentioned, the Ggplot2 package is going to be something you swear by. So if you're looking for something and it says the name of the package is Ggplot2, and then there's something that you're searching for is this, it's probably going to be the Ggplot2 thing. So just click that, and it's the same thing that we had before. Does that help? Yeah. Okay. Cool. Yeah, or just do F1, whatever is convenient for you. Also note that if I run this package, run this data set, I'm gonna get the columns, and also I'm gonna get something down here which says like CHR, that stands for characters. So like all these columns are like just like letters, characters that are put together. Same for model. DBL means double. That basically means a decimal. Different from int, which stands for integer, which is a rounded full number. And yeah, those are your basic, like your most basic data types you're gonna have to use. Note that if like this is an integer, I can't have like 1999.999 because that would not be a full number. So that won't fit in. Okay, now to something different. We use the read_CSV file and the read_Excel file to read in any sort of external files that we're gonna use. In this case, for the MPG, we just don't need to read anything else because we just read in the library Tidyverse, and Tidyverse contains MPG. But let's say that I'm using, for example, this, oh, I deleted it, but like the 4NA dataset that I was using, and I downloaded my computer. So if I have something in my computer that I want to put into R, I would choose read CSV. CSV is just like a file extension. So like it will be like file name .csv, like it would end in .csv. That just means comma separated, I think, variable. Basically, it's like a text file that has like, for example, it would have Audi, comma, A4, comma, 1.8, comma, 1999. Like it separates each value with a comma, and it's just like another thing as a like an Excel file or just another format. Yeah, comma separated values. Thank you, Nico. Yeah, so read CSV is what you use to read in those files. Let me just open the help menu, put my mouse on top of read CSV, F1, just tells you what it does, description, etc. And if I go to usage, note that the help menu is like bundling up different functions like read the lim, read CSV into like one help file. When this happens, I just like scroll down and look for the one I'm looking for, which is read CSV. And the first parameter of this function, like the first thing that goes within the parentheses, is the file path. In this case, the file path is like this, which goes always any path, any sort of string, like any string of characters, such as this, goes within double quotes. Unless, like, for example, df would not go within double quotes because it's not a string of characters. It's like referring to a variable or an object or like a table. But if it's something else like a file path or just like something that you like an output that you want to print to the console, such as hello, you put it within double quotes. Any questions about read CSV and file path, file name, that sort of stuff? Okay, sounds good. Shortcut for Mac users. I don't know about Windows. I'm gonna have to check this. But if, for example, I wanna, let's say I have this CSV file that I use for my job. It ends in .csv, so I know it's a CSV file, and I can read it using read_CSV. I find this file on the Finder in Mac. I right-click, and then if I go down to copy and press Option, see that it changes from copy, press Option to copy the path name. So if I just copy the path name and then paste to this, so let me just delete this and paste my file, then you're gonna see it being read in. So that's just a much faster shortcut than like typing users / my name / downloads / whatever. So yeah, just do that. Have to check about Windows, but still that's how it works. Okay. So DF in this case stands for data frame. You're going to notice that many data scientists or data visualizers, when they write DF, they mean data frame. It's just shorthand. It doesn't have like any special, like it's not a keyword in R such as like mutate, which is a keyword because it's a function name. So you can just like use DF freely, but you're going to notice that many people, when they write their code and when they first read in a file, they're going to call it DF, data frame. That's just convention. Like read in your first file, call it DF, or if you have like a better name, just like presidential data, that works too. It's just the name to refer to the table. Okay, great. Again, a tibble, any combination, any table that has rows and columns in the source data in R. Great. Just a review of pipes that we did last time. Remember that the pipe is the name for this operator, percentage, caret, percentage. Pipe takes the argument that is to the left, which is usually the data on the left, and does something, do something using function on the right. Okay, so the pipe takes the data frame or the tibble that is on the left, and it's going to do something to the right. So for example, I take a data frame, I do mutate, I write whatever argument I want to write. Note that I can pipe again. For example, like this pipe would take all of this, which is what is on the left of this pipe. It would take the result of this and then do something again. So like imagine I want to filter, for example, which we're going to look into later on in the workshop. So I can do like multiple pipes, and that just means like instead of like having to do a separate table for each step, I can just do like one. I can save it once. So like saved data frame, save df. Use this arrow operator, which is option -sign or alt. I think it's -sign in Windows too, or plus, one of the two. So if I do pipes, I just have to like save this object once, versus if I don't do pipes, I'm gonna do saved df first step. I'm gonna do okay data, or like I'm gonna do mutate. My first argument is gonna be data, and then whatever else. And then I'm gonna have to do another one that says saved data first second if I want it to be saved. And then I have to do, again, another, let's say, so I just take save df first and then filter that and do whatever. So see how this is like much easier, saves a ton of space. That's why we highly encourage the use of pipes. We know it is a bit of a more complicated concept, but again, we're here to answer any questions. If there's any questions about pipes right now, better to clear them out because we're going to be using them a ton throughout the workshop. So yeah, any questions about pipes? Nope. Okay, cool. Just as a clarifier, if I use a function like mutate, for example, we're going to see that the first parameter that mutate takes inside its parentheses is .data. That just means if I go down to the arguments and see .data, that means a data frame or a tibble or whatever. So if I do data on the left, pipe mutate, then I don't have to write the .data argument down here as I did, right? I'm saving space because mutate that like the pipe is going to make mutate assume that whatever is on the left of the pipe is going to be the first argument, aka data. Yeah, like most functions that like do something with a table are going to take data as their first argument. If you're in doubt, you can always check the help menu and see like what the order of the arguments is. The order is important, by the way. You have to like put them in the order that the help file says. Okay, cool. So conclusion, pipes make your life easier. Don't worry about this thing. This is just like to assign whatever is all of this to this variable called safetyf. The pipe takes this on the left, puts it into this function on the right. Then this pipe takes everything on the left, puts it into this function. And the result of that is saved to safetyf. Okay, is that clear? Any questions? Oh, I have a chat. Wait. What sorts of things go inside mutate again? Good question. Yeah, the help file is not very helpful in this case. It has ... which says name value pairs. The name gives the names of the column, and the value can be anything. Remember that mutate adds new variables to a table. So to add a variable, I would do like name of the new column equals the value that I want to give the new column. Note the difference between when I assign something to a variable or a data frame, I use the arrow. But when I do like name value pairs, I use the equal sign, one single equal sign. Know the difference. Using an equal sign here is bad style, and people are not gonna like it. Okay. Yeah, you can just like transform the data. So like do whatever data times 2 or something, and you can do like comma and like second column, whatever, equals whatever. Yeah, and is that kind of clear? Is that good? Great, cool, thank you. Yeah. Okay, so we're gonna go into plotting data finally. Let me just run the chunk opening the MPG dataset now. Yeah, so again, you see that we have all these variables within MPG, and imagine that I want to plot CTY, so city miles per gallon, I think it is, in the x-axis, and highway miles per gallon in the y-axis, right? Obviously, I can't choose a variable that is not in the table. Like otherwise, R is not going to understand what I want it to do. So make sure that your variables are in the table. Great. So when we use ggplot, let me just pull in better style FNF1 to open the help menu. Okay, ggplot creates a new plot. Basically, declares the input data frame from a graphic for a graphic, and then specifies how that graphic is going to look. Okay, so let's go like step by step. First argument that ggplot takes is data. That is the name of the data set that you're going to be using. In this case, the name of the data set we're using is MPG, right? Second argument is a list of aesthetic mappings to use for the plot. Okay, so aesthetics. This is something a little bit different. Aesthetics. Whenever you want to assign aesthetics to a graph, you have to use the AES function. Now, if we go to AES in the help menu, it takes an argument for x, which is what like data should be matched to what aesthetic. So like it takes an x argument. In this case, their argument for the x-axis is city miles per gallon from this. So like we take MPG, then ggplot looks, okay, this is the MPG table. Does MPG have a CTY variable? Yes. Okay, put that into the x-axis. Next, does it have a highway variable? Yes, put that into the y-axis. If it doesn't have the variable, it's going to throw an error. So make sure that you're reading in the right table and the right column name. It also takes a y argument, evidently. And it can take other arguments, such as it can take like color. In this case, if we're like doing a scatter plot with points, it's gonna like this is gonna set the color of the points. So like color equals, for example, red, Remember to put red in double quotes because it's a string, or like put the hex number of whatever color you're using. This is, I think, for white, I think. It can take like if you're like doing shapes, it can take the fill, like color is like the outline. The fill is like the inside of the shape if it's big enough to be seen. You can do like the size equals like 1 or the size equals 10 or whatever. There's a ton of other things you can do. I think that there's like a full list of things that you can do with aesthetic mappings. There's a list. Let me see. Okay, I'm gonna send you the cheat sheet somewhere, but it's somewhere here. And yeah, there's a ton of things you can do, ton of ways you can use aesthetic mappings, but crucial part is always setting what goes in the x-axis and what goes in the y-axis. Okay, so that's it for this line. Do I have any questions about like reading in data and Ggplot or like doing aesthetic mappings? Any other questions? Okay, sounds good. Okay, so let me just delete this second part and try to run this chunk. If I run this, what is going to happen is Ggplot, what Ggplot does is it creates an empty plot with values for the x-axis, which is CTY, values for the y-axis, HWY, and it's not going to plot anything for you. It's just going to put like the grid lines in, and that's going to be it, right? What if I want to do a scatter plot? Well, I have to add a new layer. The plus sign here is to add a new layer. So there's a ton of layers which we call geoms. Let me just show you what types of geoms are. So let me just open the cheat sheet, Ggplot geoms. Yeah, this is a cheat sheet. There's a ton of cool things that you can do. If you go to the cheat sheet, which I'm going to send in the Slack later on, you have, for example, if you have like one variable that's continuous, you can have like a frequency thing. You can have a histogram. You can have like just bars. Geom bar like takes an x variable and does like the count. You could do, for example, if you have, where is this? If you have two variables, an x and a y. In this case, we have two variables. We have set an x variable and then we have set a y variable. We can use geom point to make a scatter plot, for example. We can do geom jitter, which is the same thing, just that like moves a point, like jitter moves the points around randomly so that like they're not all stuck together, which in some cases makes it easier to see. You can have geom smooth, which draws like a line of best fit, usually a curve from your points. Geom text to like write values. This is really cool. Geom hex like takes a number of points, like divides the plot into like different small squares, takes a number of points in each small square, and then like the color of these represent the number of points or like the density of the points, which is like useful if you have a ton of data that you can't see. So that's basically it. In this case, we want to do a scatter plot, simple one. Scatter plot was geom point. So we do add plus to add a new layer, and then we write geom point with parentheses because it's like a function. And then we run this. And see, now we have all the points plotted. Within this, we can add another layer. What if we try geom smooth? And there we go. Line of best fit with like I think there's a confidence interval, this gray area around it. What if we want to do something a little bit more creative? What if we want to, I don't know. Let's say we want to insert a third variable, but we want to keep this like a 2D graph. Let's say that we want to color the points by let's say the year that they were made in. In order to do that, we'd have to use aesthetics, right? Aesthetics sets everything, like all the variables that we're using in the graph, all the colors, all anything. So in this case, I'm going to set the color variable, the point equal to the variable year. What is the problem with this? Give me 1 second. Let me see if I can do it for geom point. Yes. Oops.
I think it's the extra plus.
Oh, you're right. Yeah, thank you.
No problem, no problem.
Yeah, usually like put all your things inside one simple AES statement, the single one. Color equals year. There we go. Thank you, Nico. Okay, so it's going to paint the points differently based on the year that they were made, and it's going to add a legend. Whenever you add something that it's not like X or Y, it's usually going to add a legend. Imagine that we want to do something else, like make it even more extra. For example, make a different size based on like drive. We set size equals DRV. And the size of the points is going to change based on the drive. Another legend that is added here. Yeah, here it tells me using size for a discrete variable is not advised. Why? Because there's only going to be like 3 different sizes. But if I want to do something continuous, like let's say displacement, it's probably going to be a better use of size. Okay, so like there's a much bigger diversity of like the size of the points and makes them like much clearer. Good. Okay. Any questions about Ggplot, how it works, adding layers, adding geoms? Okay, sounds good. Just to make a small clarification, if I add something like color inside the AES, this is a whole AES statement, the aesthetic statement. If I add color inside AES, I probably have to set a variable. Like I think I can't do just like color equals red. Yeah, I can, but it's gonna come out as the legend. What if I don't want the legend to be there? I just cut this and put it outside the AES as an extra argument. Color equals red. Oh, don't tell me this is not working.
Do it within the geom point.
Okay, thank you. Oh god, what a disaster. YouTube is gonna see this. This is open to the world. Okay, there we go. So all the points are colored red and we don't have the legend down here. Imagine that I want all the sizes of the points to be 2. I would take size away from the aesthetic statement. As Nico said, always put like, if these are like general things that affect all your points, put them inside the geom point and not the aesthetic. Okay. If you put something with an aesthetic is to like set something to a variable, like set size based on a variable. If you put it inside geom point, it's like, it does the same thing for all the points, as you can see here. Cool. Any questions about this? Okay, sounds good. Yeah, we just did that. Okay, so basic template for, before the basic template. Remember while we talked about pipes. The pipe takes whatever is before, in this case MPG, and assigns it as the first argument, in this case data, of Ggplot. So for the second example, I don't have to write data equals MPG. No longer necessary because we already set the data argument here. Can you also put in HTML color codes? I believe so. Like you mean like hex codes? Yes, I can. For example, if I make 0 to 0, 6 values. Okay, this is black, for example, or like FFF, or like whatever. This is 6. Yeah, it's 6. And to pink, for example. Okay. Yeah, coming back to my point. If I use a pipe, whatever is left in this MPG is going to be interpreted as the first argument, which is the data. So I don't have to write data equals whatever. I can just start with the second argument, mapping equals whatever. Okay. And this is going to do the exact same thing as what I did with all the extra stuff. As you can see, both plots look the same. It just makes your life much easier to do MPG, pipe it in, instead of having to write like the data argument separately. Cool. So whenever you want to plot your data, how you do it, you put in the data set that you're reading from to the left of the pipe, just like make a new line because it's good style, but it's not going to affect anything. It's just good style. And then pass it into Ggplot and just write mapping equals the aesthetic and whatever, X equals whatever variable, Y equals whatever, etc. And then you add a new layer and add geoms. Know the difference between piping a data set to a plot and adding a new layer. When you pipe, it's this, Shift Command M, or Shift Control M in Windows. When you add, it's just like adding something on top of the blank plot space that we saw. Am I missing something I wanted to say super quick? No, I think I'm good. Yeah. Oh, yes. Remember, imagine that I'll go back to the sheet and I want to do like one variable instead of 2 variables. I'm going to use gmbar just for this example. So imagine gmbar is for like one variable that's continuous. Actually, it should be discrete, honestly. But yeah, okay. Imagine I want to do a GM bar with a drive, or with, yeah, let's do the drive. I think it's just easier. So I'm gonna put in the data set, pipe it into Ggplot. My first argument is gonna be mapping equals the aesthetic function. For the X variable, I'm gonna have the, what did I say it was? The drive. I'm not gonna have a Y variable because I want it to be like count the number of cars that have that drive. So I'm just gonna do geom bar, and that's basically it. See, so I'm gonna have all the different drives, and I'm gonna count how many rows contain that drive in the table. Cool. Any questions about this before we move on to the activity? Sounds good. Okay, this is the link to the plot thing. We're gonna send it over Slack too, but in any case, you can download it from the resources thing that we have, the resources drive that we have um in the Slack that we share. Okay, I'm just gonna stop recording, and we can move on to activities.